Okay, so we continue with 3.2e. So in this subtopic, you will learn to form a strong inductive argument of a certain situation. Alright? Form a strong inductive argument of a certain situation. So a strong and cogent inductive argument depends on the true premises and conclusion. Remember, a strong and cogent inductive argument depends on the true premises and conclusion. The given premises are the evidence or support to the conclusion meant. Inductive reasoning can be carried out in the following step. Alright? You can follow this step to perform inductive reasoning. The first one, you observe some examples or specific situation. And then you observe the common features and then make a general conclusion. Okay, you refer to example 22. Form a strong inductive conclusion for each of the following number sequences. Look at A. Sequences 1 over 1, 1 over 2, 1 over 3, 1 over 4, and so on. Okay, 1 over 1 you can write as 1 negative 1 exponent. 1 over 2 you can write as 2 negative 1 exponent. 1 over 3 equal 3 negative 1 exponent. 1 over 4 equal 4 negative 1 exponent. Okay, you observe it. This is a specific situation. Then you observe the common features. As you can see, the common features here is negative 1 exponent, negative 1 exponent. All of these number have negative 1 exponent. Alright, and then as you can see, the value of this number 1, 2, 3, 4 is changing. So we can represent this changing value with n and then rewrite this common feature, negative 1 exponent. So negative 1 here. So n negative 1 exponent. And then comma, and then you write down the value of n, where n 1, okay, 2, 3, 4. 1, 2, 3, 4. Comma, dot, dot, dot. Okay, usually we write down 3 dots. And then you look at this number sequence B, 0.5, 0.25, 0.125, 0.0625, and so on. Okay, 0.5 you can write as 0, 1 exponent. 0.25, 0 power of 2, sorry, 0.5 power, 0.5 power of 1, and then 0.5 power of 2, for 0.125, 0.5 power of 3, 0.0625. We write as 0.5 power of 4. Alright? Now, you observe the common features here. Common features here is 0.5. Okay, 0.5. Okay, so you write down 0.5. Okay, inside the bracket. And then write down the changing value. To represent the changing value with n. Okay, with n. So 0.5 power of n. Alright, and then you write down the value of n 1, 2, 3, 4, and so on, dot, dot, dot. Then you refer to C for sequence 1, 3, 5, 7. Okay, you can get it for Now we refer to example 22C for sequence 1, 3, 5, 7. Okay, here we show the step how to get this sequence. For example number 1 is equal to 2 times 0 plus 1. For number 3, 2 times 1 plus 1. For number 5, 2 times 2 plus 1. For number 7, equal to 2 times 3 plus 1. As you can see here, the common features here is 2. Alright, so you write down 2, rewrite 2. And then for the changing value, you present with n. Okay, addition here. And then 1. So you write down, rewrite 1 here. So, and then you write down the value of n. So here it start with 0. 0, 1, 2, 3. Alright. And then for the last example, for sequence 0, 9, 24, and 45, and so on. Alright. So here is the step how you obtain the number sequence. For number 0, 3 times 1 power of 2 minus 3. So for number for 9, 3 times 2 power of 2 minus 3. And 24, 3 times 3 power of 2 minus 3. And for 45, 3 times 4 power of 2 minus 3. Alright, so as you can see here, here is the common feature 1, 3, 3. So 3, then 1, 2, 3 is changing, so it present with n. And then here 2, the common feature, so n power of 2 minus 3. Okay, minus 3, where n, so you write down the value of n, where n 1, 2, 3, 4, comma, and then dot, dot, dot. Alright. Then you can do set practice 3.2e. You do number 1 until number 4. So that's all. Later on we continue with 3.2